Okay, start recording or started. Okay, welcome everyone. Thanks for joining us today. My name is Ani Aiken, and welcome back. You're watching episode 3 of our YouTube series Domain 3 Data Preparation of the AWS Certified Machine Learning Engineer Associate Exam Guide, something to that effect.
Hi everyone, I'm Ava and I'm really glad to be here with you, Aniakan, today, and we're going to talk a lot about data pre-processing.
Absolutely, yes. In episode 1, right, everyone remember we covered data processing overview. In episode 2, we dove into data collection and ingestion. Today, as I said earlier, episode 3, we're unpacking data pre-processing, the crucial step before you feed data into your model.
That's right, Aniakan, and you can think of pre-processing like tuning the engine of a car before a road trip. It makes sure everything runs smoothly when you hit the highway, in this case, the highway of machine learning.
I love it. Highway of machine learning, very cool. So first up, data cleaning. That's the process of fixing or removing incorrect, corrupted, or incomplete records, like proofreading a manuscript before you publish it, or in Ava's case, checking your tire pressure before going on a road trip.
Great, great. So what happens if our data set has missing entries?
Great question. Real world data often has gaps. Um, Yeah, and there you have three main options. One, replacement with constant values. This is also known as this is also known as again, this is also okay. Real world. I'm sorry. Three main options: replacement with constant values, and this is where you fill missing spots with a fixed placeholder like zero or even negative 999. So, if, for example, if you have numerical values, you want to put something in there that it can be a placeholder. If you have categorical values, you might use unknowns or not applicable. And the analogy, or so this is like filling out a form where you don't know someone's city. You would write something that will fit, that will not be out of place, that will allow you to continue processing the data, something like not applicable. So you're using a standard placeholder to indicate missing information in a way that can still be processed. And you'd
Great.
use this um, when you want to maintain that when the fact that something is missing carries its own meaning, like there was no response to that question. For example, you want to be able to track how many people did not respond to a specific question in a survey. So that's when you would use something like this.
Very interesting. Very interesting, Aniakan. And then we also have statistical imputation, and this is going to be the mean or the median. And those are essentially simple statistics. The method works for numerical data only, by the way, and assumes that missing values are going to be random. And the mean versus median, folks, just a quick refresher here. The mean is going to be the normal average, and then the median is going to be the mid spot when you sort all the values. Let's think of an analogy for this as well. It is like estimating the typical temperature for missing readings in a weather data set by using the average of known temperatures for that time of the year.
Nice. And then the third one we have predictive imputation. So this is where you train a predictive model like KNN, like the K nearest neighbors, or a regression. You train a predictive model to estimate missing values based on other features. And let's say you know someone's height and weight. However, you don't know their shoe size. And maybe you need that information to maybe figure out how many shoes of a particular size to produce. Then you could create a model to look at people with similar height and weight to predict the shoe size.
Oh, that's a great analogy again, Naniakan. And so after handling those missing values, we need to catch something called outliers and also duplicates, right?
Yes, exactly, exactly. So outliers are extreme values that can mislead your model. And duplicates, just as the name implies, are duplicates or repeated records that can bias results.
Got it.
So, and we want to detect it. Yeah, we want ways to detect it. One way we could detect outliers, or to detect outliers, we could look at things like the Z-score method and the IQR method, or even visualization. And in the Z-score method, which I will have a visual of, we flag any value more than, say, three standard deviations from the mean. IQR, similarly, we use it, we compute what's called the interquartile range, and then flag points between this range and this range. I'll have the visual that I can point to. Now, the third outlier detection method is just visualization. Maybe we use things like box plots or histograms to use that to spot anomalies.
Oh, very interesting. So, Onyeka, can I offer an example of an outlier from my area of the Pacific Northwest?
Please, love it.
So Bill Gates' mansion, which is valued at over 180 million, is an example of an outlier because its price drastically deviates from the typical home values in Medina, Washington. So if we were to look at the mean, it's going to be significantly pulled upward because of this extreme value. And on the other hand, the median is going to become or remain, I should say, relatively stable since it only considers the middle value. So this is a side note here, but median is often preferred over mean when analyzing housing prices, as it is more resistant to the influence of these extreme type of outliers.
I love it. I love it. And I also love the fact that you found a very, very, very nice way to slip in that fact. Bill Gates is my neighbor. No, just kidding.
Ah, ah.
No, so very cool. So the other way is the other method of data cleaning is duplicate removal. Duplicate rows skew your model towards patterns that appear too often, right? In tools like Python's pandas, you would use a function like drop duplicates. In Spark data frames, you would use another function like, a similar function called drop duplicates as well. And it's like accidentally sending multiple invitations to the same email. You only want one invite per person. All right. So now the next topic is data partitioning. So once our data is clean, what do? I think the next step is we take that clean data or data set and we split it into up to three different data sets: training, validation, and test sets. Right, Ava?
Oh, that's right, Onyeka. So imagine that you're studying for an exam. The training set is going to be your practice questions. The validation is going to be the mock tests that you use to tweak your study strategy. And then the test set is going to be the final exam. An example split, and this is just an example, is going to be 70% training, 15% validation, and 15% test. Some scenarios use just train and test, though, that is commonly used in cross validation, and then different split ratios may be appropriate based on the data set size.
Mm, very cool. And cross validation is a good one to know for the exam, right? It is a resampling technique specifically useful if you have limited data. A common type of cross validation is the k-fold cross validation. And so with k-fold cross validation, the data is divided into k equal folds. And that k is typically 5 or 10. And with each iteration, one fold becomes the validation step. And I'll have a graphic of this. One fold becomes a validation step. The remaining k folds form the training set. The model is trained and evaluated. And next we talk about process. So next, the process repeats, and it repeats k times with each fold serving as validation once. And the final performance is averaged across all k iterations. By the way, Eva, how does AWS help with data partitioning?
Oh, there is definitely a tool for that in Yakan. In Amazon SageMaker, there is a built-in functionality to partition data right inside SageMaker Studio, so you don't have to write custom code for splits. They just provide it in SageMaker Studio.
So SageMaker truly does almost do everything
Yeah,
for
I would
us.
say
Effective machine
pretty
learning.
close to everything.
Yeah,
So next, let's talk about scaling. Before models can see numbers like heights or prices, they need all features to be on the same scale. So no single feature can dominate in some way just because the values are larger.
nice, absolutely. Yeah, if scaling is needed, it's typically a two-step process, right? Because scaling may not always be needed depending on your data, but if it is needed, we typically follow this two-step process. That is, before we scale, we check if a pre-scaling step such as handling outliers or converting units is needed. And so let's say we do need that pre-scaling step. So we talk about unit conversion. Unit conversion is where we make every feature use the same unit. For an example, you might convert, or you would convert, kilometers to meters, so that features speak the same language, so to speak. There are some algorithms that, or in general, algorithms treat numbers as what are called naked values with no units attached, no units metadata data attached. Now, once you've gone through that first step, the unit conversion step, the next step is scaling. Scaling brings every feature into a comparable numeric range. This is like turning everyone's microphone volume to the same level. Or you're at a party and you're having people having conversations. If one person is very loud, they dominate the conversation. You can't hear anybody else. So scaling essentially brings the conversation down to a level that is bearable for everybody. And there are two scaling methods: normalization, also called min-max scaling. And this is where we squash the values, quote unquote, squash the values into a fixed range. And that fixed range, the min-max scaling, typically uses a range of between 0 and 1. So let's say you have songs that are playing at different volumes. You normalize them so that the quietest one is at 0, the loudest one is at 1, and then everything else, all other songs in that playlist, scales proportionally between those two values. And you'd use this, for example, when you have distance-based algorithms like KNN that we mentioned earlier, and also many neural networks. And a good exam tip to know for this is know that min-max scaling transforms each feature's values to fall between 0 and 1, where the minimum value becomes 0, the maximum value becomes 1, and all other values are proportionately scaled between them, between 0 and 1.
Yeah, that's a great exam tip, Aniakan.
Yeah, thank you.
Great. So let's talk about standardization next. This is also known as z-score scaling. And what it does is that it's going to center data around 0 by subtracting the mean from the value and then dividing by the standard deviation. Maybe you can think about a teacher who is going to transform raw test scores into how many points above or below of the class average you are. And so the score is going to, at average, is going to become a 0. And you'd use this for algorithms that assume normally distributed data, such as linear or regressive or logistic regression, folks.
Yep, very cool. All right. And I don't know if I should even ask. This is supported in SageMaker, right, Ava?
Yes, you know it, Niekan. In SageMaker Studio, Data Wrangler offers point-and-click, in fact, transformations for both min-max scaling as well as Z-score standardization. And you can complete it with before and after histograms as well, so you can see the effect visually.
Very cool. Right. So now let's talk about bias and imbalance. That's when some groups or classes in your data are overrepresented or even underrepresented, which can make models unfair or inaccurate.
Yes, so first you detect imbalance using charts like histograms or pie charts. It's like checking that both teams have equal number of players, if you will. There are also bias metrics you can use. We're going to see this in our upcoming demo. And then you, of course, need to mitigate the imbalance with, for example, there is oversampling technique. There is a technique called SMOTI, which is synthetic minority oversampling technique. This is going to create synthetic examples of the minority class. But the minority class is the one that is underrepresented. Duplication simply repeats existing minority samples. Then we have undersampling. That's kind of the opposite. It's going to remove or delete excess majority samples. You can also do random sampling where you pick a subset to reduce the dominance.
Very cool. Very cool. And the third technique we'll cover today is class weighting. And so this assigns higher importance or weights to minority classes during model training. That is, instead of changing the data itself, it modifies how much each class influences the model's learning. So it's like giving certain players certain players more voting power in team decisions to ensure that their voices are equally heard. And a good example for this is um, that class weighting is useful when you want to keep all original data. However, you need to balance model sensitivity.
I think you asked me here if it's time for demo. I just added this, so you might have not seen it. Sorry about that.
All
I thought
right.
you might, yeah.
Yes. So very good. Thanks. Sorry about that.
Yeah, no
So
worries.
Ava, it is. Sorry. Can you scroll down to that point? So Ava, what time is it? Is it time
it
for?
is it is demo time, Maniakan.
Very
Yes, it
cool.
is. So
All right.
let's see a demo. Today we're going to see a demo on bias detection with the use of a SageMaker again service called SageMaker Clarify. And this is going to be in a Jupyter notebook. So let me share my screen real quick
Okay.
here, and then we're going to take a look at it.
All
All
right.
right. Can you see my screen okay?
Okay. That's
Great.
great.
And as a side note, you don't see my account or anything, right?
I do
Okay.
not, I see just a SageMaker
Okay. Great.
clarify. Yeah.
Perfect. So that's what I figured it out. Okay, this was all the record. Okay, so this is, as I mentioned, there is a service in SageMaker called SageMaker Clarify, and you can use this service through the SageMaker console, but also you can use it programmatically, and I'm going to show you an example of that. And SageMaker Clarify is used for detecting bias in data and also in models. Today we're focusing on detecting bias in data because this is our topic, but know that Clarify can also be used for model bias detection as well. And so here I have a Jupyter notebook, and this notebook runs interactive Python scripts. I have already pre-ran them for us. So this is going to install some packages, and including it's going to install the SageMaker Clarify uh, report is going to be imported from SageMaker Clarify bias package. And this is going to be used to test against various bias metrics here. It's going to use a marketing data set. And so the first step is going to be we're going to need to grab the data set from an S3 bucket and put it in a temporary directory so that the SageMaker can work with it and Clarify can work with it while analyzing. Once this is available into the environment here, you can run various data frame commands. You might be familiar with them. So you can say columns here. So these are the columns in this data set. And so it has age, job, marital status, education, and so on. And the goal here, by the way, is to predict how many of these people are going to respond to a call, right? And so it's going to be, again, a marketing campaign. The next here head is going to show us the first 5 rows of data, and that's by default. You can change this number, but you can see examples of the kind of data stored in the data set. So for example, just here we have a 56-year-old married housemaid, and they've been contacted, etc., etc. And then paydays is going to mean when they were contacted, and the most recent, it could be actually, if it's 999, it means they were not previously contacted. So it's just using like an encoding for that 999 to represent that.
So that's
And
like the placeholder, a standard placeholder we were talking about earlier, right? It's like
that's
using
right, yeah.
Yeah, cool.
Great point, absolutely. And also in Yakan, as we mentioned previously, you can use some visualizations to quickly get a sense of the data. So this is not yet using Clarify, but you can use in this case, it's a pair plot. And what it shows us, even if we visually look here, so the x-axis is going to be, let's say, a campaign, and then the y-axis is going to be, in this particular plot, the age. And just visually looking at that, I can see here that most of the people who were contacted were, 60 years or younger, right?
Mm.
And so that's just something to keep in mind. We're going to see if it's also replicated in the metrics, bias metrics, but that's something I'm calling out here. And of course, we can keep on going, but that's one data point here to note.
Cool.
And then we have the target outcome here, which is going to show how many responses responded yes to the campaign, which is this number here. And then these are the ones that are the no's, they did not respond.
So is this an example of an imbalance, a class imbalance?
In this case, this is just the target outcome. So I would say that it's more like this is the outcome. It was produced as so the target outcome.
Okay, so
This
this
is what
is
it
not
is.
okay. It's not the
Yeah.
okay. It's just okay. Forget about that.
Yeah. No, it's a great question. So this is just showing us the outcome, and maybe I should take it out of the.
No, that's good.
Potentially, let me know.
That's
So
good.
this is just an overview. And now here we're going to get to the point to calculate those pre-training bias metrics. And here, as I mentioned, let's see, where did it go? We have some, I'm going to remove some of these charts. There are too many charts here, so my bad. So I just wanted to get to this one. So here, folks, we have the bias report from Clarify, and this is where this is going to use the defined columns that are existing in the dataset to measure the bias. And in addition, one other interesting detail here, this is going to say the education level is a confounding variable. In other words, the bias, does it exist with or without the education group in place? So confounding for education. And now these are examples of different metrics that are specific for bias folks, and there are a lot of them. You should know, at least familiarize yourself for the exam. The first one here is the conditional demographic disparity label, and the value is 0.0068. The next one is the class imbalance that you mentioned here, Aniakan, and those are for different thresholds. So the data has been split into middle, young, and old. And without looking at every single line of data, what I would like to point out here is it turns out with this CDDL value being negative 0.3.4, the metrics, the bias metrics show that there is some kind of bias against the older age group. And so there's a strong evidence here for that based on the metrics, particularly as I mentioned, the CDL, but also the class imbalance here. and the DPL, which is difference in positive proportions in labels as well. And even with different education layers, this persists. So knowing all this, again, the point is here, we do have a tool that allows to measure this, and this is Clarify. There are different bias metrics that you can use. And maybe the last point to make here is how do you mitigate? We need to maybe talk a little bit about mitigation strategies here as well. And they're going to be to, for example, collect your data in such a way that you balance the group representation because you saw that there is already an imbalance there. Um, Also, maybe you want to continue providing this regular bias monitoring, and then also you can use those SageMaker Clarify reports produced to implement those mitigation strategies, but they're now backed by metrics. So this is what I wanted to show you today, and we're going to share with you a blog next week if you wanted to try this yourself with a notebook.
Very cool. This is great stuff, and yes, I'm looking forward to that blog. I know our viewers will be as well. So thank you for that, Eva. All right, thank you for that, Eva.
Yeah, absolutely. My pleasure as always.
Okay.
Great. So we actually have one other topic to discuss, which is data augmentation. And that data augmentation is going to be artificially expanding your data set so your model gets more practice examples and becomes more robust. What kind of techniques do we have there, Anyakan?
Yeah, great question. So we have techniques such as synthetic data generation and image augmentation. In synthetic data generation, this is where we algorithmically,
It's a hard
say
word.
that one time fast, algorithmically creates new records from scratch. And image augmentation is where we essentially we apply different techniques. We apply rotations and crops and flips to existing images to create additional images to yeah. So it's like looking at an object from different angles.
Nice.
AWS even offers built-in augmentation pipelines in SageMaker for both image and text data, so you can automate those transformations.
Yeah, I think it's safe to say you can do everything in SageMaker.
Yes,
Great. So let's go ahead and recap at this point. We talked about data cleaning, which handles missing values, constant replacement, statistical or model driven, and also about the detection of outliers and duplicates. That's part of the data cleaning as well.
absolutely. And we also talked about data partitioning. So this is where we split training, validation, and test sets using stratified splits for balance.
We also talked about scaling techniques, converting units, then normalizing them from 0 to 1, or maybe standardizing them, which is a zero-centered technique.
And there was bias and imbalance. So we detect skew and mitigate with oversampling and undersampling and class weighting.
Great. Is this the next one mine?
Yes,
Okay.
I
Okay.
apologize if I didn't
No
note that.
worries. I'll just add a note here. Okay. And then we have data augmentation, where you expand the data sets with synthetic data or transformations. And again, SageMaker pipeline is going to make this easy.
That's right. All right, folks, that's it for episode 3. Next time in episode 4, we'll dive into feature engineering, where we transform and combine cleaned data into the most um, informative inputs for our models. You won't want to miss it.
Yes, absolutely. See you in episode 4, everyone. And don't forget to like and subscribe. Till next time.
Till next time, thumbs up. Everyone, thank you. All right, very cool.
Thank you. Great.
Recording.
All right.
That was 29 minutes.
Whew.